You might think understanding Amazon PPC is just about, picking the right keywords or setting your bids. But the truth is, there's a seriously sophisticated technical brain behind it all. It's really far more complex than just a simple auction these days.
Absolutely. It's really evolved, hasn't it? It's become this deeply technical system that influences, well, pretty much everything an advertiser does.
Exactly. So today we're going to take a deep dive into the technical implementation and the machine learning aspects of Amazon's advertising ranking system. We're basing this on the sources you've shared with us,
Right.
our mission, to really understand how Amazon's system actually works under the hood, the
hmm
technology, the algorithms, how it handles data, and crucially, what that means for you as an advertiser listening in.
Yeah, we'll dig into the core algorithms, the ones deciding which ads pop up. We'll look at how the system remembers historical performance data. That's what we're calling ranking memory. Then we'll dive into the powerful machine learning models making the decisions, see how it balances that past performance with what's happening like right now,
hmm
and understand how it keeps the data accurate, deals with anomalies, and finally touch on the absolutely massive computing power needed to make it all happen.
Okay, sounds like a lot to cover. Let's jump right in. So let's start with that core decision maker, the algorithm that, powers Amazon's current ad system. People often call it the A10 algorithm, right? And it's meant to be a major shift from the old A9.
Yeah, that's right. The A9 era, which was roughly up until, say, 2023, was much simpler from a purely technical viewpoint. Its main focus was pretty direct sales velocity and keyword relevance.
So basically, if your product sold well when people searched for certain terms, A9 liked you. Simple as that.
Pretty much, yeah. It heavily favored, keyword bid dominance. It was a classic second price auction model and very focused on those immediate conversions.
Ah,
It prioritized listings with a click-through rate, a CTR of sub 0.4% or higher, and a conversion rate, CVR, of 8% or more.
right.
And this created this powerful feedback loop, Top performers got more visibility, which led to more sales, which just reinforced their top position.
Makes sense.
Yeah, there was actually a study, I think it looked at 10,000 sponsored products campaigns. It found that A9 allocated a striking 70% of ad visibility to listings that already had historical sales velocities in the top quartile.
Wow, 70%.
Yeah.
That's a huge advantage if you were already doing well.
hmm
So what changed technically with A10? How did they shift gears?
Well, the A10 transition, starting around 2023, marked a shift towards a much more complex AI ecosystem. It began balancing not just those immediate sales, but a wider range of factors. It started looking at the whole marketplace dynamics, trying to understand deeper user intent, and crucially, how products perform outside of Amazon.
Outside Amazon, how does it technically even factor that in? That feels like a really big leap.
It is. It really is. One of the key technical innovations was actually valuing external traffic. The system began rewarding products that drove qualified traffic from other places. Think social media, like clicks coming from TikTok shoppable posts, for example.
Interesting.
And these products started seeing significant organic ranking boosts, sometimes 2 to 3 times what they might have gotten otherwise.
2 to 3 times just
Wow.
from external clicks.
Qualified ones, yeah. And the data showed a direct impact on ad efficiency, too. Advertisers who generated at least 15% of their clicks from off-Amazon sources saw their advertising cost of sales, their ACOS, drop by a remarkable 40% compared to those running purely PPC campaigns.
40% lower ACS. That's a massive technical signal than linking off-platform actions directly to on-platform ad rank.
Exactly. It's a big change. And another technical shift was bringing seller authority metrics right into the ranking algorithm.
So not just about the product anymore.
Right. It's also about the seller's reliability. They introduced this sort of composite seller score. So, for instance, sellers keeping their order defect rate, the ODR, below 1%. They gained a 20 to 30% visibility advantage.
20 to 30% just for good customer service metrics.
Yeah. And inventory stability became technically critical too. Listings with a stockout frequency of 5% or less. They retained 92% of their ranking momentum during restocks. Compare that to only 67% for products that frequently ran out.
Wow, so stocking out really hurts your momentum now.
It does, and review velocity was added in there too. Products getting 4 or more verified reviews each week often outranked comparable competitors by 1.8 times.
So things like keeping stock, managing customer issues, getting reviews, they now directly, technically impact your ad visibility through A10.
They absolutely do. It's a technical integration of your operational health into those core ranking signals. And the third big piece was A10 leveraging Amazon's, massive machine learning infrastructure, AWS, for much more advanced AI-driven personalization.
Okay, like,
Well, things like contextual bidding, dynamic bid adjustments based on context. So maybe increasing bids by up to 50% for mobile users or up to 75% during those peak evening hours, say 7 to 9 p.m. local time. Or even, interestingly, decreasing bids by 30% when the system sees more than 3 rivals targeting the exact same keywords, like if it gets too crowded.
So bidding isn't just a manual thing anymore. The system itself is making these adjustments in real time based on all this context.
Precisely. And they also technically improved how the system handles searches that aren't just text. Think image search, voice search. Sponsored product models began processing image and voice queries,
Right.
which significantly improved ad relevancy, especially for visual-first categories, things like apparel or home goods.
So the system is essentially seeing or hearing what someone is looking for beyond just the keywords. That feels like a huge technical step up from simple keyword matching.
It really is. These technical innovations together show that A10 is, well, it's a much more sophisticated, multifaceted AI system compared to A9. It's factoring in this whole wider universe of signals to figure out ad rank and relevance.
Okay, so this really sophisticated A10 system is collecting all this data, clicks, conversions, seller metrics, external traffic, even how you searched, like voice or image. How does it actually remember all of this and use that history to influence future ad performance? Let's talk about this ranking memory.
Right, ranking memory. From a technical standpoint, it's not just about, storing raw data logs somewhere. It's really about how the system retains the influence of that historical performance data, how that history shapes current and future ad rankings. Think of it like the system learning from its past experiences.
Okay, so it's the impact of the history, not just a data dump. Got it. How does it technically link all this history to one specific product, even if you're running, say, sponsored products and sponsored brands for it?
Yeah, the central technical identifier for all of this is the ASIN, the Amazon Standard Identification Number. Every product has its unique ASIN, and that acts as the linchpin, the primary key, that links all performance data for that specific product.
Ah, okay.
Regardless of which campaign type generated it, sponsored products, brands, display, whatever, all clicks, impressions, conversion events, they get tagged to that ASIN.
So the ASIN is basically the product's permanent advertising performance record within Amazon's system.
That's a great way to put it, exactly. And technically, Amazon uses these powerful distributed databases, likely things like AWS DynamoDB or similar tech, to log all these events with the ASIN metadata attached.
And how quickly does this information get updated across the system?
It's fast. Different parts of the advertising system, like campaign managers, they update these ASIN level metrics very frequently, often every 15 to 30 minutes via APIs.
Wow, near real-time updating across the whole ad ecosystem. Okay, so it's tracking everything by ASIN. How does it decide which ad actually gets the credit when a sale happens for attribution?
Right, attribution. Amazon primarily uses a 14-day click window. So basically, the conversion gets credited to the last ad the customer clicked within that 14-day period.
Okay, standard enough.
But crucially, for the algorithmic ranking memory, it also uses view through attribution. This is important. It means if you see, say, an impression from a sponsored display ad for a product, don't click, but later see and click a sponsored products ad for the same product and then buy it. The system logs that entire path. It knows the display ad was seen, and it rolls that information up to the ASIN level, retaining that data for its algorithmic use, even if the conversion is only officially attributed to the sponsored products ad in your campaign report.
I see. So the algorithm itself sees a much fuller picture of the customer journey than what might show up in our standard advertising reports.
Yeah.
It's key. And this ranking memory, this influence, how long does it actually last?
This is a really critical technical detail and often misunderstood. While the raw data reports you can access have shorter retention periods, like sponsored products data via the API is typically available for 95 days. That's actually up from 60 days previously. Sponsored brands is 60 days, sponsored display 65 days, and detailed reports in the console often expire after 60 to 90 days.
Okay.
The algorithmic influence, the actual ranking memory itself, can persist and affect your rankings for up to 180 days, 6 months.
180 days. So even if I can't pull a report on something from 5 months ago, the algorithm might still be using that performance data to rank my ads today.
Essentially, yes. That historical influence lingers algorithmically, and this duration has a really significant impact on ad performance. For instance, ads that maintain consistently good performance, let's say a CTR of 0.5% or higher, and a CVR of 10% or higher for 30 or more consecutive days, they start receiving sustained visibility boosts from the algorithm.
Okay.
And on the flip side, products that have, say, 180 days of strong sales history, they tend to retain about 85% of their organic ranking momentum, even if you have a temporary hiccup like running out of stock or pausing your bids for a bit. That history provides a buffer.
Ah, that explains why those established, consistently well-performing products seem to have this sort of inherent advantage, this resilience. You mentioned evergreen status earlier. Is that technically related to this long memory?
Yes, exactly. That's a key concept driven by this long-term ranking memory. Consistent high performance specifically, achieving a CTR of 0.8% or higher and a CVR of 12% or higher for 90 consecutive days or more can lead to what's termed evergreen status.
And what does that mean technically?
It means the algorithm essentially grants that product an enduring preference. It reduces its dependency on aggressive bidding over time. That history earns it a kind of algorithmic trust.
That's a really powerful technical incentive for maintaining long-term high performance. Okay, what about performance across different Amazon marketplaces, like, say, the US versus the UK or Germany? Does this ranking memory transfer?
That's a good question. The system largely operates at the marketplace level, so ranking memory is primarily localized, meaning the CTR and CVR thresholds that matter, the sales velocity calibration, they're all unique to each region because they're based on local customer behavior, local demand patterns, and external traffic attribution is also specific to the marketplace the traffic actually landed on. So a really strong 0.8% CTR in the US doesn't automatically give the same algorithmic weight or benefit to the same product's listing over in the UK.
So you essentially have to build up that performance history, that ranking memory, separately in each country you sell in.
Exactly. You're building local memory. However, there is a bit of nuance. Some global seller credibility metrics do technically carry over.
Like what?
Well, a low order defect rate, keeping it under 1%, that impacts your standing globally across your accounts. Also, severe inventory instability in one major region can sometimes trigger a bit of algorithmic caution or skepticism elsewhere. And having brand registry, that can provide a slight technical edge, contributing to maybe 10 to 15% faster ranking momentum when you launch that registered brand in a new marketplace.
Okay, so mostly local, but some account-level factors have a global echo. That's helpful. How does the system handle performance data differently, coming from mobile users versus desktop users? Their behavior can be so different.
Yeah, this is technically quite sophisticated. The system doesn't just lump it all together. It tracks metrics like CTR, CVR, and even cross-device attribution separately for mobile and desktop sessions.
Separately, yeah, okay.
And it even normalizes some metrics. Mobile CTRs, for instance, are adjusted to account for smaller screen sizes and, the fat finger effect. So maybe a 0.5% CTR on mobile might be considered algorithmically equivalent to a 0.8% CTR on desktop for the same ad.
Ah, so it adjusts expectations based on the device.
It does. And desktop CVR is often weighted higher for products where customers typically do more research high consideration items. So maybe a 12% CVR on desktop could be seen as more significant than an 8% mobile CVR for, say, a complex electronic gadget.
So it understands the context of the device and the likely user intent.
Precisely. It factors in behavioral intent signals. Mobile-first intent may be quickly checking local inventory, shipping speed that's weighted differently than the deeper research behavior often seen on desktop, like time on page or scroll depth.
Right.
Ad placements also differ hugely between mobile and desktop, right? How ads integrate into search results. The system adjusts its CTR expectations based on placement, too.
Okay, so the weighting is dynamic.
Very dynamic. Mobile CTRs might get, say, a 1.2 times multiplier in the algorithm. Desktop CVR for those research-heavy products might be weighted 15-20% higher. Mobile CVR might dominate for quick consumables. It even understands cross-device paths, maybe deprioritizing mobile bounce rates for categories where users browse on their phone but tend to buy later on their computer.
It's analyzing behavior at a really granular device-specific level there.
Yeah.
Okay, one last thing on memory. What happens to all this accumulated history, this ranking memory, if account ownership changes? Say, when a business is sold, does the memory go with the account?
That causes a significant technical disruption. It's not a clean transfer. Roughly 30 to 60% of that ranking memory is tied to account-specific metrics,
Like what?
like the historical order defect rate for that account, the sales velocity history associated with that specific seller account, and the past PPC campaign performance history run from that account. These metrics can essentially reset or lose their historical weight for the new owner.
So the new owner has to rebuild that part.
Yes, it can mean it takes, maybe 30 to 45 days for the new account to rebuild that specific layer of algorithmic trust. However, the product-specific metrics, things like reviews, the organic rank, which is tied to the ASIN itself, external traffic signals linked to the ASIN, those retain some partial equity if the ASINs remain the same and aren't relisted under new ASs.
Okay, so some continuity if the ASIN stays. What about suspensions?
Yeah, verification suspensions are bad news for memory. They unfortunately cause a near total loss of visibility, usually a 90 to 100% drop for maybe 14 to 30 days while things get sorted out. It really hits the momentum hard.
That really underscores that Amazon's system sees the product history and the seller's account history as deeply intertwined when it comes to calculating ad performance and rank.
It absolutely does. They're technically linked.
Okay, so Amazon is collecting, storing, tracking this massive amount of detailed performance data, this ranking memory, for up to 180 days of influence. What's the actual intelligence layer? What uses all this information to make those critical decisions about which ad to show me right now and for how much?
Right, this is where the really sophisticated machine learning models come into play. Amazon employs, well, a whole suite of these ML models. Their purpose is to constantly analyze that historical data, blend it with real-time signals, and then optimize everything, add visibility, relevance, predicting the likelihood of a click or a conversion.
A suite of model. Okay, what kind of technical models are we talking about? What are they actually doing?
Well, one core model type you'll find is what's known in the field as a learning-to-rank engine, or LTR, often based on things like gradient-boosted decision trees.
Okay, LTR. What's its job?
Its main function is to predict the best order of ads to show in the search results. It uses historical data, CTR, CVR, sales velocity, to optimize this ranking. Technically, it's trying to maximize a blend of objectives like sales, maybe profit, inventory levels, while ensuring the most relevant products bubble up.
And it uses that history.
Heavily. These models explicitly assign higher weights to ads that demonstrate that sustained strong performance over time, like maintaining a CTR over 0.8% for 90-plus days. That directly contributes to the Evergreen status we talked about.
Got it. So LTR models figure out the best display order based on historical success. What else?
Then you have models that are much better at understanding context and language. These are often based on advanced architectures like transformer networks, similar to what powers things like BERT.
Transformers, like an AI language model.
Exactly. Their job is to process natural language queries from users and the text in product titles, going beyond just simple keyword matching. They try to understand the actual meaning or intent behind a search. They also evaluate the quality of the whole set of results shown together.
So they improve relevance.
Significantly. Research suggests these can outperform traditional LTR models by 15–20% in some tests and improve things like exact match CTR by maybe 35% because they understand semantics better. They help match ads to what a customer is really looking for, even for complex or, visual searches.
Models that truly understand intent, not just words. Okay, what other types?
Another really important category involves models used for dynamic decision-making and what's called exploration versus exploitation.
Exploration versus exploitation.
Yeah, think of it like this. The system knows some ads work well, exploitation, but it also needs to try out new ads or ads for new products to see if they work, exploration. Models based on reinforcement learning principles, like contextual multi-armed bandits, are great for this.
Multi-armed bandits. Sounds like Vegas.
Yeah, the name's evocative. Their role is to constantly balance showing those proven ads versus experimenting with newer ones. This is crucial for giving new products a fair shot, helping reduce that cold start penalty maybe by 30–40%. They are also the models that can quickly react to reward signals, like driving that 15% or more of off-Amazon clicks with those 2–3x ranking boosts.
Okay, so they help new products get discovered and quickly reward things like external traffic. Makes sense. What about personalization?
Right. Personalization is key. For this, they often use models like neural collaborative filtering, or NCF. These models look at your specific past interactions on Amazon, what you've viewed, clicked on, bought before.
My personal history.
Exactly. They build these like user behavior profiles or embeddings and use them to predict which products and ads might be most relevant to you specifically right now. The goal is to show you ads you're more likely to click on. Studies show these can achieve maybe 19% higher CTR for returning customers compared to generic ads.
19% higher CTR.
Yeah, and they also understand that recent behavior is usually more predictive, so they incorporate a decay factor, maybe 8–12% weekly decay on the influence of older interactions, while still remembering your long-term preferences.
Personalized ads weighted towards recent activity.
Oh, got it.
Any others?
Yes, another important set handles inventory-aware bid optimization. These might use techniques like deep Q networks, DQN, another form of reinforcement learning.
Okay, DQN for bids.
Yeah. These models adjust bids in real time based on factors like your current stock levels and also how crowded the auction is, how many competitors are bidding hard on the same terms.
So they know if I'm about to run out of stock.
Exactly. This allows the system to automatically pause your ads if you do run out, which protects your performance history, like we discussed. And then when you restock, they can automatically increase bids, maybe by 50–75% during peak hours like 7–9 p.m., to help you regain visibility faster. Some data suggests this cuts the recovery time after a stock out by half.
Wow, so bidding becomes predictive and directly tied to my inventory and the competition, second by second.
Pretty much. And finally, it's worth mentioning models designed for privacy-compliant data utilization. Amazon might use techniques like federated learning here.
A federated learning?
Yeah, it's a way to train machine learning models on decentralized user data that stays on user devices or in secure enclaves without needing to bring all the raw personal information into one central place. This allows the system to learn from broad user behavior patterns while complying with privacy regulations like GDPR, maintaining maybe 85% prediction accuracy even for sensitive categories.
So they can get the benefits of learning from user data without compromising privacy in the same way.
That's fascinating. What a complex ecosystem of different AI models, each doing a specific critical job.
It really is. They all have to work together seamlessly, processing that ranking memory and those real-time signals to constantly optimize how ads are delivered across the platform. Okay, it's clear these models are using both that long-term historical data, the ranking memory, and also what's happening right now, the real-time signals.
Yeah.
How does the system technically do that balancing act? How does it decide how much weight to give past performance versus, say, a sudden spike in competition?
Right. It's not like a switch flips between historical and real time. It's a continuous dynamic process, really managed by that whole machine learning framework we just discussed. The system doesn't treat history and real-time data as separate buckets. It blends them using very specific technical weighting mechanisms.
Okay, and how does that weighting technically work? Is there a formula?
The core mechanism is often described as a dynamic algorithmic weighting system that heavily favors recent data. Think of it like this. The performance data from the most recent 30 days. That accounts for approximately 60% of the overall ranking weight in many models.
60% from just the last month. Wow. So recent performance is really, really critical then. It carries most of the immediate weight.
Absolutely. Achieving good CTR or CVR this month has a much stronger immediate impact on your ad rank than what happened, say, 4 months ago.
Okay, so 60% recent. What about the older data from day 31 back to day 180? That remaining 40%.
Right, that data from days 31 through 180 collectively contributes the remaining roughly 40%. But, and this is key technically, its influence decays over time. It's not a flat 40%. It decays exponentially.
Right, exponentially. How fast?
The typical decay rate is estimated to be between 8% to 12% per week. And interestingly, this rate can even vary depending on the product category's volatility.
How so?
Well, for faster-moving categories like, say, electronics, where trends change quickly, the decay might be steeper, maybe closer to 12% per week, whereas in more stable categories, like perhaps home and kitchen, the decay might be gentler, maybe around 5% per week. The system adapts the memory fade based on the market dynamics.
So the older the data gets within that 180-day window, the less influence it has. But it doesn't just drop to zero overnight. It fades out gradually, and the fade speed depends on the category.
Exactly. It's a gradual fade. And this decay model is precisely how that evergreen status concept provides value. Remember, products that maintain that consistently high performance like CTR over 0.8%, CVR over 12% for 90-plus days, they build up significant long-term algorithmic equity.
Right.
This equity, built over time, allows them to retain maybe 60 to 80% of their visibility even during temporary disruptions, like if you pause bids for a week or have a short inventory gap. It demonstrates the lasting power of that consistent historical performance despite the decay model trying to fade older data.
That makes perfect sense now. Consistent, strong performance builds a more durable, decay-resistant ranking memory. Okay, so that's the historical side. How does the real-time data fit into this picture? How does it interrupt or modify that historical weighting?
Yeah, while the historical data with its decay sets a kind of baseline or potential, the system is constantly processing immediate signals to adapt right now. Inventory status is a prime example we touched on.
When you run out of stock.
Exactly. If a product goes out of stock, the system automatically pauses the ads. And this isn't just about saving you ad spend, it's a technical measure to protect the product's relevance score within the algorithm. Showing an ad for something you can't buy leads to bad clicks. Zero conversions that hurts your metrics.
Ah, so pausing protects your history.
Right. Then, when the stock is replenished, the system doesn't just turn the ads back on. It can resume them with significantly increased bids, potentially 150 to 200% bid boosts, to quickly regain momentum and try to offset the negative impact of that recent pause in visibility.
So real-time events like stocking out aren't just operational issues. They're directly factored into the ranking system's immediate calculations and reactions.
Yes, absolutely. Competitor actions are another key real-time signal. If the system detects sudden auction crowding, let's say more than 3 rivals suddenly start bidding aggressively on your core keywords, it might automatically reduce your bids by, say, 30% in real time.
Why reduce them?
To prevent your costs from skyrocketing unnecessarily in a bidding war, it's an automated adjustment based on the immediate competitive landscape and, like we mentioned earlier, driving that significant external traffic, hitting that 15% or more attributable clicks threshold from off-Amazon sources that immediately triggers those 2 to 3 times organic ranking boosts. That's a real-time signal integration right there.
Okay, so the system is constantly performing this intricate dance, using its long memory, applying the decay to older data, and reacting instantly to what's happening in the marketplace with inventory, with competitors, with external signals, all at the same time.
That's precisely it. And the machine learning models, the LTRs, the Bandits, the DQNs, they are specifically designed to synthesize this complex blend of historical trends and immediate real-time events. That's what makes the system so highly adaptive and sometimes, frankly, hard to predict moment to moment.
With all this incredibly detailed data being collected, stored for months, and used to make these complex, high-stakes decisions, ensuring the data is accurate and doesn't get corrupted must be absolutely critical. I mean, if the historical data is bad, the algorithms will make bad decisions,
Oh,
right?
absolutely. Data integrity is utterly foundational. The algorithms, especially the ML models, are only as good as the data they're trained on and the data they use for predictions. Garbage in, garbage out, as they say.
So how does Amazon technically handle this? How do they ensure the integrity of petabytes of data over 180 days and deal with any anomalies or errors that creep in?
They use a really robust, multi-layered technical framework specifically for data integrity and anomaly handling. It's quite complex.
Multi-layered. Okay, break that down. What's the first layer?
First, they use technical methods to verify the data's integrity right from the moment it's stored and periodically afterwards. This involves using cryptographic checksum algorithms. Think of these like unique digital fingerprints for chunks of data. Common ones are things like CRC64, SHA256.
Checksums, okay.
These checksums are graded when data is uploaded, say, to their storage systems like Amazon S3, and they're checked again later to detect any accidental corruption, like bit flips during storage or transmission. They also structure the data storage in a way that's very hard to tamper with, almost like a blockchain. Updates don't overwrite old data, they create new versions, each with its own hash, providing an immutable audit trail.
So they check the data when it comes in, check it periodically, and keep a tamper-proof history of all changes.
Correct, that's the verification layer. The second layer is massive redundancy and automated repair systems. Data isn't just stored in one place.
Right, backups.
Way beyond simple backups. It's technically replicated across multiple physical locations, usually at least 3 distinct AWS availability zones, which are separate data centers. They use sophisticated consistency checks to ensure this replication is accurate, aiming for incredibly high durability, like 99.9999999%. That's 11 nines of durability.
11 nines. Wow.
And they use techniques like erasure coding. This means data objects are split into many small pieces, data shards, and parity shards. If any few pieces get corrupted or lost, the system can automatically reconstruct the original data from the remaining pieces, often within hours, using algorithms like Reed-Solomon.
So the data is spread out redundantly, and if a part of it breaks, the system can actually fix itself automatically.
Exactly. That's the redundancy and repair layer. The third layer involves using machine learning itself to detect anomalies and potential errors within the data streams.
Using ML to check the data.
Yes. Systems like Amazon Monitoring, for example, analyze historical patterns in key metrics like CTR and CVR. They learn what's normal for a specific product or campaign, and then flag deviations that are statistically unusual, say something that's more than 2 standard deviations away from the norm. Basically, flagging numbers that look weird compared to past trends.
And what happens if the system flags something as weird?
It triggers an anomaly response. This could involve automatically quarantining the suspect data, maybe trying to replace it with data from a clean backup, or triggering a recalculation of the ranking memory components using verified data.
Okay.
And interestingly, that power law decay model we discussed earlier also provides a passive form of protection. If a subtle historical inaccuracy did creep in but wasn't detected, its influence naturally diminishes over time anyway because of the decay, minimizing its long-term impact on current rankings.
Ah, that's clever. Bad old data just becomes less influential on its own.
Right. And alongside checking historical patterns, they also have real-time detection systems focused specifically on identifying invalid activity and potential fraud, like bot clicks or click farms.
Trying to catch fake clicks.
Exactly. Systems like SLDR, that stands for Slice-Level Detection of Robots, use deep learning to analyze traffic patterns in near real time. They look for irregular activity, like sudden, unrealistic spikes in CTR, maybe over 300%, and can often identify suspicious campaigns within about 48 hours.
48 hours. That's pretty fast.
Yeah, it segments traffic into slices to analyze it fairly, and uses techniques like weak supervision to learn fraud patterns. When it flags something, it can trigger actions like freezing suspicious campaigns or adjusting the weight given to bids from anomalous traffic sources.
So dedicated AI systems constantly watching for fake clicks and unusual activity patterns in real time.
They do. And layered on top of all this are strict technical access controls and auditability, using what's called a zero-trust architecture with IAM policies to tightly restrict who or what can access and modify the sensitive ranking data.
Locking it down.
Exactly. And every modification attempt is logged immutably using services like AWS CloudTrail with those cryptographic hashes, creating a verifiable audit trail. The data itself is also encrypted both in transit and at rest using strong algorithms like AES-256 GCM, with encryption keys managed securely and rotated regularly, maybe every 90 days. They're even looking at quantum-resistant encryption methods.
So access is locked down tight, every change is tracked forever, and the data itself is heavily encrypted.
Precisely. And then you have operational safeguards like scheduled integrity scans run by backup systems, maybe weekly checks using those checksums, and the ability to restore data from deep, long-term archives like Glacier Deep Archive if absolutely necessary, although that takes longer, maybe 48 hours. It's a really comprehensive belt-and-braces technical approach to ensure the data foundation of the entire ranking system is as sound and trustworthy as possible.
It sounds like an absolutely enormous amount of technical effort and infrastructure goes into just keeping the ranking data clean, safe, and accurate. Which brings us to the next point. What kind of computing power does all of this actually require? You've hinted at the scale, but can you give us a sense of the resources involved?
Yeah, the computational requirements for this entire system are, well, they're truly staggering. Just starting with storage, the sheer volume of data is immense.
How immense?
Well, even just the basic performance metrics for a single product might generate, say, 1 to 2 kilobytes of data per day. Now, multiply that by hundreds of millions of products active on Amazon globally. You're talking potentially 100 to 200 gigabytes of new performance data logged every single day.
Gigabytes per day.
Which adds up fast. That's 36 to 73 terabytes per year. And remember, the system retains influential history for up to 180 days. So the active historical performance data being managed at any given time is likely in the range of 18 to 36 petabytes.
Petabytes. Just for the advertising performance history, that's almost impossible to comprehend.
It's huge. They store this using highly scalable distributed databases like DynamoDB and object storage like S3. And they rely heavily on efficient data formats like columnar formats such as Parquet or ORC, which can compress the data by 75–80%, significantly reducing storage footprint and cost maybe by 60%.
Okay, so massive storage, cleverly compressed. What about processing it all in real time?
That's the next challenge. For real-time processing, handling every single ad request when someone performs a search, the system needs incredibly low latency. The budget is often around just 120 milliseconds to receive the request, query the ranking memory, run the ML models, score the ads, hold the auction, and return the winning ads.
120 milliseconds for all that.
Yes. And it needs to handle incredibly high throughput, potentially processing upwards of 500 million requests per second during peak shopping periods globally.
500 million requests a second.
Yeah. This requires extensive use of in-memory caching systems like Redis or Elasticache, which can retrieve frequently accessed ranking memory data in just 5 to 10 milliseconds. And behind the scenes, massive data streaming platforms like Kinesis are processing potentially over 1 trillion events daily to feed near real-time updates back into the ranking memory and ML models.
Trillions of events daily. Okay, so it has to be able to look up history and process new data almost instantly, millions and millions of times a second. What about the ML part? Training and running those models.
That's another huge computational load. They're training maybe 100 or more different complex ML models daily, often on these petabyte-scale datasets derived from the ranking memory. This requires enormous distributed training clusters, using potentially thousands of powerful GPUs, graphics processing units, often things like NVIDIA A100s.
Thousands of GPUs just for training.
Yeah, using these large GPU clusters can reduce model training time by maybe 60%, which translates to huge cost savings, potentially millions of dollars per month compared to using less specialized hardware. And that's just training. Then you have inference actually using the models to score ads.
For every server.
For every relevant ad for every search. The system might need to score 10,000 or more potential ads for a single ad request. To do this efficiently at scale, they deploy specialized AI accelerator chips like AWS Inferentia, which are designed specifically for high-throughput, low-cost inference. These chips can handle maybe 100,000 inferences per second at a fraction, maybe 1/10, the cost of using general-purpose GPUs for inference.
Dedicated hardware optimized just for running the AI predictions quickly and cheaply. That's a serious technical investment in the infrastructure.
It absolutely is. And the entire system is built on distributed computing principles. Data is partitioned, maybe by ASIN hash, across potentially 10,000 or more database shards. Processing is split regionally, North America, Europe, Asia, to reduce latency, maybe by 40%. Huge clusters running frameworks like EMR process, maybe 500 billion records daily just for data aggregation and feature engineering for the model.
So everything is broken down, processed in parallel across a massive global network of servers.
Exactly. Even the anomaly and fraud detection systems, like SLIDR, require significant dedicated resources. They might analyze over 200 different signals per impression using specialized models, flagging maybe 0.2% of campaigns daily, which could still be around 2 million campaigns a day globally, requiring maybe 50 or more dedicated server instances just for fraud detection. And the network infrastructure has to support all this. Using services like AWS Global Accelerator with over 100 edge locations worldwide to reduce latency by maybe 30%. Deploying across multiple availability zones for that extreme high availability we mentioned. And using auto-scaling systems that can dynamically adjust the number of active servers from maybe 10,000 during quiet periods up to 500,000 or more during peak events like Prime Day, often using cost-effective spot instances for maybe 70% cost savings on compute.
From 10,000 to 500,000 servers, scaling instantly.
Yeah. And there's constant cost optimization happening too, using tiered storage fast, expensive SSDs for hot data, cheaper S3 and Glacier for colder data, saving potentially $8 million a year for every 10 petabytes stored. Optimizing database queries to reduce processing costs by 40%. It's a constant balancing act between extreme performance, massive scale, and cost efficiency.
This isn't just a ranking algorithm. It's a full-blown, planetary-scale, real-time computing operation, constantly learning and adapting just to power the advertising system we interact with every day.
It truly highlights the hidden technical complexity and the sheer scale of resources Amazon dedicates to making this advertising engine work effectively.
Wow. This deep dive has really pulled back the curtain on the sheer technical complexity behind Amazon PPC. It's far more than just bids and keywords.
It's quite remarkable when you start to understand that technical foundation, isn't it?
Absolutely. So let's try and quickly summarize the key technical and machine learning aspects we've covered in this deep dive, just to bring it all together.
Okay. So at its heart is the A10 algorithm. It's the core brain, and it's evolved significantly from A9 to be heavily AI-driven. It's not just looking at direct sales anymore. It's incorporating a much broader range of signals, things like external traffic, your seller health metrics, user intent.
Right. And the system's memory, that ranking memory, it isn't just about storing raw data logs. It retains the actual influence of your historical performance for up to 180 days, much longer than your reports might show. And it links everything meticulously to the product's ASIN using sophisticated attribution models that see more than just the last click.
And powering all the real-time decisions. That's a whole suite of complex machine learning models working together. You've got models specifically for ranking the ad order, like LambdaMart, models that understand the meaning of searches, like Transformers BERT, reinforcement learning models, like Bandits, that balance trying new things versus sticking with winners.
Models for personalization based on individual user history, like NCF. Models that optimize bids based on real-time inventory and competitor actions, like DQN. And even models designed for privacy using techniques like federated learning. It's a whole ML toolkit.
Exactly. And the system is constantly performing that critical balancing act between using that long-term historical data, applying that power law decay, where recent data counts for roughly 60% and older data fades, and reacting instantly to real-time signals like stock levels, competitor crowding, or incoming external traffic. These ML models are designed to blend history and the present moment.
And underpinning all of this is a massive technical effort to ensure data integrity. They're using multiple layers, cryptographic checksums, extreme redundancy across data centers, automated data repair, AI-driven anomaly detection systems like Monotron and SLIDR to catch errors and fraud, plus strict access controls and encryption, all to make sure the data the algorithms rely on is accurate and safe.
And finally, none of this, absolutely none of it, would be possible without truly massive computational infrastructure. We're talking petabytes of data storage, processing trillions of events daily, needing hundreds of millions of calculations per second, using thousands of GPUs and specialized AI chips for training and inference, all running on a dynamically scaling global cloud platform.
So understanding these technical layers really reveals how Amazon's system actually determines your ad visibility and your costs. It explains why things like consistent historical performance, keeping your operational house in order, managing inventory, getting reviews, and even driving traffic from outside Amazon are all technically factored into that complex algorithmic equation.
Precisely. It makes you realize that pretty much every action you take as a seller, every metric you see on your dashboard, is ultimately a signal feeding into this giant, complex, constantly learning machine that dictates a huge part of your success on the platform.
It's really an AI-powered advertising engine, through and through.
It truly is.
Well, this has been an absolutely incredible deep dive into the technical core of Amazon PPC. Thank you so much for guiding us through all that complexity.
My pleasure. It's a fascinating and constantly evolving system to unpack.
Definitely. As we wrap up, here's a provocative thought for you, our listener, to consider. Given the absolutely massive computational power and the sophisticated AI models Amazon is clearly using today, and with mentions in the sources hinting at future advancements, things like generative AI, maybe even quantum computing down the line.
Yeah, where could it go next?
Exactly. What incredible new ways might Amazon's ranking memory and its algorithms evolve in the future? How might they start predicting intent or valuing signals in ways we can't even imagine yet? And maybe more importantly, how will sellers like you need to adapt your strategies to compete effectively in an even more technically complex and intelligent landscape ahead?
The pace of change in algorithmic advertising isn't slowing down, that's for sure. It really does make you think about future-proofing your approach.
It really does. Think about the implications for your own strategies. How do you prepare for a system that's only going to get smarter, faster, and more deeply integrated? Lots to ponder there. Thanks again for joining us on this deep dive.